Conflict archaeology is a term that for many of us conjures up images of archaeologists on their hands and knees excavating historic battlefields or other material remains of war. However, in reality, this growing subdiscipline within the traditional field of archaeology is much more than that. Most relevant to sites dating from the early 20th century onwards, it promotes the integrated use of non-destructive methodologies and demonstrates that alternative tools to spades and trowels are available. Peter Masters, a research fellow at Cranfield Forensic Institute, has been able to take his experience in the commercial area of geophysics and apply it, together with other non-destructive techniques, to support his research in conflict archaeology.
My research aims to establish how, through the integration of non-invasive techniques, it is possible to classify the typology of landscape features, add interpretation to sites of historic interest, and show what was originally there.
Peter is curious as to what lies beneath the landscapes of the Great War, and in particular the frontline trench systems. His research, built up over a number of years, has taken him from the English countryside of Salisbury Plain to areas of the Belgian and French countryside that witnessed some of the fiercest fighting of the Great War of 1914 to 1918. During World War I, large areas of Salisbury Plain were given over to training Allied troops for trench warfare. Many miles of practice trenches were dug here, and although some still survive, the majority were backfilled at the end of the war. Using equipment designed and built by Cranfield University, a gradiometer survey was carried out here in a bid to enhance the understanding of trench warfare remains and the configuration of the trench systems. The results were encouraging, and revealed amongst other things that the typical trench system was made up of three key components: the front line, communication, and support trenches. In 1916, the 33rd Battalion of the Australian 3rd Infantry Division underwent 5 months of intense training at Salisbury Plain in preparation for the rigours of war. Their time here was just one leg of their long journey to war that began in Sydney and ended in the Ypres region of Belgium. Their first major battle did not come until mid-1917, when they took part in the Battle of Mersin. Following in the 33rd Battalion's footsteps, Peter too took the knowledge he had gained at Salisbury Plain to the battlefields of Belgium. His work with the Plugstreet project, or Plug Street as it was known to the British troops, demonstrates in practice the premise at the core of his research: the value of taking an interdisciplinary approach to conflict archaeology. Geophysical survey work, aerial photographic interpretation, and data gathered from the other archive resources, such as trench maps, would be used to inform each other on the project.
I was one of a multinational team, and together we set out to discover the story of the Battle of Mersin, one of the least known but perhaps one of the most decisive battles of the Great War. Ironically, once again I was to cross paths with the 33rd Battalion of the Australian 3rd Infantry Division.
Towards the end of 1914, the character of the Great War changed from a moving war into a standstill in the trenches stretching along the Western Front. The Allies were unable to break through the German lines, and a grinding stalemate prevailed. Despite fierce fighting, the Germans continued to dominate the Ypres salient and the high ground on the Messines Ridge. To break the German lines, the Allies dug 22 mine galleries filled with explosives beneath key German positions along the ridges of the entire Messines front. The Battle of Mersin commenced on the 7th of June 1917, with the successful detonation of 19 of the mines. Following the explosions, 9 infantry divisions advanced, and the 33rd Battalion of the Australian 3rd Infantry Division succeeded in taking this section of the German front line. The week-long battle was later described as a successful prelude to the main offensive at the Third Battle of Ypres, known as Passchendaele. The Plugstreet project concentrated its efforts on the area surrounding the positions known as Ultimo and Factory Farm, where 2 of the mines were detonated. From the end of 1915 onwards, photo reconnaissance units were regularly sent out to record the outline of the enemy's defences. The aerial photographs taken survive in large quantities. 38 dating from 1915 to 1918 were retrieved from British, Australian and German archives and geo-rectified for the project. All were taken within a 1 kilometre radius of Ultimo and Factory Farm. The interpretation of these images resulted in a detailed inventory of the entire trench system, giving a true representation of what was constructed above the ground. The data gathered showed how the war features had accumulated and evolved over the duration of the conflict. As the trench system moved from German to Allied occupation, it was modified and developed. something it would be much harder to understand by looking at material remains or trench maps in isolation.
The geophysical work here took place over several years, and in total 16 hectares of battlefield were surveyed, including areas of no man's land and the ground around the mine craters. 2 geophysical survey techniques were employed at Plugsteert: gradiometry and earth resistance. Gradiometry allows a rapid mapping of magnetic variation, which allows us to see structures and features within the subsoil. Earth resistance involves passing an electric current through the soil and measuring the potential difference between the probes, allowing us to map features such as bunkers and trenches.
The gradiometer survey produced a number of strong magnetic anomalies that appear to reflect the remains of the trenches and other related features. When constructed, some trenches were reinforced with corrugated iron sheets, and this aids their detection. Partial remains of both the Allied and German front lines were identified, including the communications trench known as Ultimo Avenue, and sections of the German lines near the factory farm and Ultimo craters. The gradiometer also detected several camouflage features not identified on the aerial photographs, one of which was revealed by later excavation to be the remains of a German blockhouse. This illustrates the usefulness of magnetometry in filling in the detail that other techniques miss. It is also interesting to note that the subsequent excavations by the Plugsteert project have shown that the integrated approach of geophysics and aerial photography often proved more accurate than the use of original trench maps in locating remains. The Earth Resistance Survey was concentrated around the Ultimo crater and the small wooded copse to the north of it. The results were not so defined as the magnetic responses. However, it too identified the presence of the German blockhouse that was later excavated, probably due to the fact that the remains were fairly close to the present-day ground surface. Both the project findings and Peter's ongoing research reinforce the value of conflict archaeology as a tool to use alongside more traditional techniques. A century has now passed since the Great War ended. However, despite its history being well documented, there is still much we can learn from continuing to explore what lies beneath its battlefields.